Hello guys, and welcome to this introductory lesson on Java programming for beginners. Today we're going to be addressing two main things, and the first will be why you want to learn Java. Now, I can proudly tell you that Java is one of the most widely used technologies today, one of the most widely used programming languages today, as you would find Java in almost everything. You can find Java running on almost every electronic device that you come across. First, you have here, I have written some of the different flavors of Java here and what you can use them for. The first one is you could use Java for developing text-based user interface applications. And for that, you would certainly be using the Java Standard Edition. Now, when I talk of text-based user interface applications, I'm sure you must have used the terminal on a Linux system before, or maybe your command prompt on a Windows system. And when you use that, you usually interact with your computer by typing in commands, text, and the computer, the application, interprets these texts and performs certain actions, as opposed to using a GUI application, a graphical user interface application, where you just have to click buttons. Now, the Java Standard Edition provides a lot of libraries that we're going to be seeing throughout this course, and is the base for all the other flavors of Java that you have. You can also see Java being used in the development of graphical user interface applications, desktop GUI applications, and for that you could use the Abstract Windows Toolkit, or you could use Swing. It's obvious nowadays anybody developing a GUI application would hardly use the AWT. Most people will go for Swing, and we'll look at the benefits of using Swing over the AWT later on when we go deeper into the tutorial. You can also use Java for developing mobile applications, and for these you will be using the Java ME edition, the Java Micro edition. This is basically, or I would say it's very similar to the Java Standard Edition, and it provides basically the same functionality, except for the fact that the Java Micro Edition is designed for smaller devices, for devices with limited memory, limited processor speed, and so on. You will agree with me that your laptop or your desktop, your computer, will definitely have a more efficient processor or more memory than a mobile phone. There's no doubt you have very high speed mobile devices today, but on a larger scale, computers will take the lead when it comes to memory and processing speed. Now, if we have to run the Java SE packages on a mobile device, it's definitely going to be slower. We're going to have a lot of pitfalls, memory problems. So because of that, the Java Micro Edition was created to suit development for these small devices. You also have Java being used in the development of embedded systems. If you have a microwave, a washing machine, your car has some form of program running inside, embedded program, your television set, many electronic devices usually have some form of software that control processes within, and that can be done using Java as well. We'll also see Java today on the web, and you're going to see a lot of web applications around coded in Java, and the basis for Java development on the web is JSPs, Java Server Pages, and Servlet technology. Majority, if not all, of the Java applications that you will come across, you will realize that they are all built on the basis of this technology. There's no doubt you have frameworks using the completely shadow this and you really don't see what's happening. But if you go down to the core and you look from there coming up, you realize that they are using servlets to manage many things to develop the entire system. Now, you also have the Java EE, Java Enterprise Edition, that is used for developing enterprise applications and distributed systems. And hopefully later on I would also give you a video on this. One other thing you have, sorry about that, my computer locked me out. You also have applets. Now, what are applets? Applets are Java programs that usually reside on a server somewhere, and you can download and run them on your local machine. You download them over a web. You can download them through a web browser, and you're going to run them on your local machine. So with that said, in this tutorial, we're not going to be covering all of these. We are simply going to be looking at the Java Standard Edition and development of graphical user interfaces with Java. We're going to talk about AWT and Swing, but we're going to focus more on Swing. Now, with all of these, you will see that Java provides a very broad base for you to develop on. And as a Java coder, your life becomes really easy because you can shift from one area to the other. Once you understand the Java SE, the Java Standard Edition, it's a no-brainer to get onto the other areas of Java, as everything, the syntax of the language, the rules, everything, it's basically going to be the same. You have a few differences, but once you're comfortable with one flavor of it, you're definitely going to find yourself getting into the other areas without any worries. Now, with that said, I'd like us to look at some of the characteristics of the programming language Java. Now, Java is a very simple programming language. Like I said before in our introductory tutorial, Java, when you compare Java to other languages like C or maybe Pascal, you will realize it's pretty easy because you have a lot of libraries already written and ready for use. As we go through, you're going to see how this unfolds. Java is also an object-oriented programming language, which means your programs are constructed by mimicking real-world objects. And we are going to see a lot of these when we talk about objects, classes. We're going to talk about inheritance, abstraction. Basically, everything you see, everything that you can do with objects in the real world, you're going to see your programs doing that as well. And Java is a platform-independent language. And why is that, or how is that made possible? Before I get into this, if you've written code in a language like C, C++, or maybe Pascal before, you would know that every time you write your program in a language that is similar to English. And we know computers don't understand that language. Computers actually understand binary, which means you have to convert your code into a form that the computer would understand. Now, to do that, you compile your program into machine code, and it runs on your system. Java has a slightly different principle. In Java, we have the concept of the Java Virtual Machine, which is just a software that has been developed and installed, and your Java program will actually execute on the Java Virtual Machine. So now, when you write your Java program, say we have our Java class file here, this is our Java program, we compile the program, and when we execute the program, it's going to run on our Java Virtual Machine, and the Java Virtual Machine is going to interpret our Java program, convert it into machine-readable code, and execute it on your system. Now, every system that you're going to find there, every operating system has a different Java Virtual Machine. So you have a Java Virtual Machine for Linux, you have a Java Virtual Machine for Windows, you have a Java Virtual Machine for Solaris, and maybe Mac, any other operating system that you can think of, you have a Java virtual machine for that environment. I'm sure you're going to agree with me that the number of applications we have out there, the number of Java applications we have in the market today, far outnumber the number of devices that are available. So it would just make sense to me that we develop a virtual machine for each environment, and all our applications can run on any of those environments without a problem. So once you write your Java program, you can install it on a Mac, you can install it on a Windows machine, you can run it on an Ubuntu machine, whatever machine you choose. Why? Because there's a Java virtual machine already implemented for that environment. As opposed to a language like C, when you compile your program, you definitely need to compile a version for Linux, you're going to compile a version for Windows, you're even going to compile a different version for a 32-bit Windows system and a different one for a 64-bit Windows system. You're going to compile a different one for a Mac operating system. So the fact that you can compile your Java program once and you can go run it on a Linux environment, go run it on a Mac environment, run it on a Windows environment, is what makes the language platform independent. Later on, when we compile our code, I'm going to explain more exactly what happens throughout the process so that you will get it. So if it's still a problem for you, don't worry. I'll cover that later on. Java is also a very secure programming language. First of all, it does not let you manage memory directly. I mean, it handles that for you, and it provides security by not letting you have direct access to your memory. You have other features like it running on a separate runtime environment other than your operating system, makes it secured, as well as it separates your system files from the Java application files as well. You have the Java bytecode verifier that verifies your program, or verifies the bytecode to make sure it's safe to execute on your system. You also have Java being a very portable programming language. It's also very highly performant. Now, if you want to compare it with a programming language like C, yeah, you would definitely know, or you would definitely realize Java is slower. That we will see later on. The fact that you have to compile it into bytecode and then later interpret it at runtime makes it less performant than a program that is written in C or maybe C++. But if you compare the benefits that the object-oriented nature of Java gives you, I'm sure they outweigh the little performance difference between the two. But compared to other languages like PHP and so forth, you would realize Java is more performant. Java is also a multi-threaded programming language. When we talk of a multi-threaded programming language, what do we mean? Now, I'm sure it will be best to explain this with an example. Have you ever wondered how it is possible that you are listening to this video tutorial right now? You have some document downloading behind, and maybe you have some word processing document open on your computer and you can switch from this document, or maybe you have your NetBeans IDE open on your computer and you can switch from this video and go back and you type some code and execute it and come back to the video. You keep on doing things like open the document, type in something while music is playing in the background and your download is still going on. Now, all that is made possible through the concept of multi-threading, and Java provides a good set of libraries for managing multi-threaded situations, and we will be looking at that as well. Now, Java is also an architectural neutral language. And when we talk of architectural neutral language, what do we mean? We simply mean the Java programming language is not dependent on any particular platform. If you're a C programmer, you would notice, or you would have noticed, that the size of an integer can vary depending on what environment you are running on. On some systems, you would realize that the size of the integer, the int, is 32-bit. On other systems, you would realize it's 16-bit, which means it is dependent on the architecture of the system. Java, on the other hand, is always guaranteed to be 32-bit, no matter where you are running on. There are a lot of features, good features, that Java brings into the world of programming, and we're going to be seeing that in detail as we move on. So in the next video, I'm going to show you how to set up your development environment so that we can proceed.